Okay, let's unpack this. We need to talk about a really big problem looming for tech. If you're tracking AI, all that high performance computing, well, the energy and cooling needs are just getting massive, pushing our limits right here on Earth.
Yeah, absolutely. And that's exactly why we're doing this deep dive. We're looking at StarCloud. They're an Nvidia Inception startup, and they're, frankly, pretty ambitious plan.
Mm.
Taking data centers, sustainable ones, completely off-world.
Off-world.
hmm The idea to tackle those core problems head on,
Hmm.
the huge energy drain, the intent of cooling, by literally moving the computing into orbit.
Okay, hold on. High-density computing means intense heat, right? How do you cool a data center up there? I mean, without air, without the fresh water we use down here. Doesn't it
Yeah.
just fry?
That's the really clever part. They're using the physics of space itself. Forget those massive evaporation towers gulping down millions of gallons of water.
Right, those things are everywhere near data centers.
Exactly. Instead, they use the vacuum of deep space. It acts like an infinite heat sink. They just radiate the waste heat directly out. Infrared. Poof, gone.
Huh. So no water needed at all.
None, which saves an incredible amount of fresh water, obviously. A huge benefit for us down here.
And energy-wise, I mean, up there you've got constant sunlight, no clouds, no night, basically.
Yeah.
The ROI must be potentially huge if they can tap into that orbital solar power 2047.
That's the projection. There's CEO Philip Johnston. He's crunched the numbers. And it looks like, well, a fundamental shift in how we think about infrastructure costs, even when you account for the massive cost of launching things into space.
Which can't be cheap.
Oh, definitely not.
Yeah.
But even with that, they're projecting something like 10 times lower energy costs. And, maybe more importantly, 10 times the carbon dioxide savings over the data center's life, compared to doing the same processing on Earth, that is.
10 times. Okay, that's not just tweaking things. That's a whole new ballgame for clean computing. And they're thinking big, right? I saw something about a 5-gigawatt plan.
Oh yeah, they're aiming high. A massive 5-gigawatt orbital data center eventually. Which, I mean, think about the scale. The solar panels and cooling arrays would need to be roughly 4 kilometers by 4 kilometers.
4 kilometers, that's,
Wha-
oh, wow. That scale itself brings up huge questions about actually deploying it. That's a massive engineering lift.
It is, no question.
Yeah.
But they're starting smaller, taking steps. Their first satellite, StarCloud 1, is actually set to launch this November. Relatively small, like 60 kilograms, about the size of a mini fridge, I think.
Okay, manageable. But what's inside?
That's the key bit. It's carrying the first data center class GPU into space, the Nvidia H100.
Ah, the H100.
Mhm.
In space. Okay, that's a leap. So we're talking serious processing power orbiting Earth for the first time. Like 100 times more GPU compute than anything flown before.
That's the claim, yeah, 100x more power. So they're not just, sending sensor data back. They're enabling heavy-duty data processing right there where the data is being collected.
Which gets us to this so what? Why does this matter right now? What are the immediate applications?
Well, think about the speed. The gains could be immense, maybe even life-saving. Things like real-time Earth observation, analyzing crop types instantly, predicting very localized weather patterns, that kind of thing.
And I guess that in-space processing is crucial for, like, emergency response scenarios.
Absolutely, that's a huge one. We're talking about cutting down response times for things like wildfire detection or picking up distress signals, reducing delays from potentially hours down to just minutes.
Minutes instead of hours.
That speed is critical,
Yeah.
especially when you're dealing with enormous data streams. Take synthetic aperture radar, SAR. It's this amazing tech, right? Uses radio waves for super detailed images, day or night, through clouds.
Okay, I've heard of SAR. It creates huge amounts of data, doesn't it?
Immense. The sources mention something like 10 gigabytes per second of raw data. You just physically can't beam all that down to Earth fast enough to process it in time for it to be useful in a crisis.
Got it. So processing it in orbit is the only way to get that quick, actionable intelligence.
Exactly. And they're already looking ahead, testing things like large language models, Google's Gemma specifically up there, and planning to integrate the next-gen Nvidia Blackwell platform too for even more horsepower.
This whole push to optimize computing is really something else. And actually, speaking of optimization, this deep dive is sponsored by embersilk.com. They're the answer for all your AI education and integration needs. That's embersilk.com.
So yeah, wrapping this up, what does it all mean? I think the core takeaway is that moving this kind of high-demand computing into space isn't just some sci-fi dream anymore. It's looking like a necessary engineering solution.
To solve real-world bottlenecks.
Precisely. Tackling those fundamental resource limits water scarcity, sustainable energy that are really starting to pinch the growth of computing down here.
It definitely redraws the map for future infrastructure. Okay, I'll leave you, our listener, with this pretty bold prediction from StarCloud CEO Phil Johnston. He said, in 10 years, nearly all new data centers will be being built in outer space. Something to chew on.
A provocative thought, for sure. Thanks, everyone, for tuning in to this deep dive.
And hey, before you go, please do take a second to subscribe and maybe leave us a 5-star review. It genuinely helps us keep bringing you these deep dives. Thanks.